Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 2-6, families of functions. Let's begin. First thing first, let's cross out the items that are not considered vertical. Well, if we had to think about the y-axis and the x-axis, we have our coordinate plane. The y value is going to be the vertical line, so the one that is not vertical will be the x value, which is right there. The horizon is when you look out against the horizon, that flat line that you see off in the distance. Therefore, it is not vertical because it will be flat. We have columns and rows. Rows are going to be the thing that goes from left to right and therefore is not vertical. Columns go straight up and down. You can kind of think of the columns that you see in like the Colosseum or columns that you see in houses or anything like that. Translation. A translation is a change from one form, state, or appearance to another. A translation shifts the graph of a parent function horizontally, vertically, or both without changing its size or shape. Complete each statement with the correct word of translation. The graph shows a vertical translation of the function. The toddler's language was not translatable. And the Spanish teacher helped the town mayor translate the letter. So let's first talk about translation. Translation is represented by any sort of adding or subtracting in any sort of problem that we're talking about functions and moving and transformations. All right, now there are two different types of translations that you have. You have your vertical or your horizontal. Now the vertical, your adding or subtracting will happen on the outside of the parentheses. But for horizontal, it's going to happen on the inside of the parentheses. Vertical being on the outside is because when we add something for translation, we're going to be adding it to every portion of the function. Whereas the horizontal, we're strictly adding it just to the x value. So if we have vertical, we know that if we add a number to the outside of the parentheses, like shown right here, it's going to be moving up. And if we subtract something to the outside of the function, we're going to be going down. For horizontal, if we were to add something on the inside of the function next to the x value, we're going to be going to the left, and if we were to subtract, we'll be going to the right. Some people might be thinking, well, wait a minute, if I have some form of a graph, going to the left has always been subtraction, so why do I have to add? Well, it's because when you do a translation, what's inside the parentheses is actually technically already subtracting. So if I wanted to go to the left, it's a double subtraction, which creates the positive that is shown. And the same thing goes with the going to the right being negative. It's because what's inside the parentheses are being subtracted. So if I were to subtract a positive number, it's going to stay negative. And you're going to find out that pretty much anything that's horizontal seems to be its backward form every single time. It always seems backwards. The first form of transformation that we're going to talk about is called translation. Now, we have seen translations before. A lot of the time, especially in geometry, you guys end up talking about translations a lot. Well, the very first thing that we're going to talk about is the vertical translation, which means that we're going to be going up or down. Notice, when you go up, we're actually going to be adding a number, as well as if you were going down, we're going to be subtracting a number. So adding a number to everything will be up, subtracting a number to everything will be down. One side's vertical, the other side must be horizontal. And this is where things get a little bit backwards, because if we were to subtract, normally we would think going to the left, because if you think about a coordinate plane, all the negative numbers are in the left-hand side of it. But for this case, we're actually going to be going to the right if you're subtracting, because as you can see, the f of x minus h is its own formula. So if I plug a positive number in for the h, we have a negative times a positive, which creates a negative, or keeps it a negative, I should say. All right, so we can't change that, so we know that even though it is going to the right, it is going positive. The actual number value on the inside will be negative, and more importantly, it's on the inside as well of the parentheses. So if this is going to the right, that means if we were to add, you're actually going to the left. For the same idea that this is the right, this would be subtracting a negative, which is going to create a double negative, which means that it's going to be positive. Great work. Problem number 1, vertical translation. How are the functions y equal 2x and y equal 2x minus 3 related? And more importantly, how are the graphs related? Complete the table of values. So I'm just going to kind of shoot through these each and every time, just so you guys can see them. And all this is really saying is, hey, we're going to plug this number into this equation, and we're also going to plug it into this equation and get these answers out. All right, so negative 2 times 2 gives you negative 4. Negative 1 times 2 gives you negative 2. 0 times 2 gives you 0, and so on and so forth down. Negative 2 times 2 gives you 4. Minus 3 gives you negative 7. Negative 5. Negative 3, and so on and so forth. So we have a negative 2, negative 4. So we go to negative 2, go down to negative 4. We also have a negative 2, negative 7, but that's off the page. We have a negative 1, negative 2. And you're going to notice that it's going to start going up in this pattern. All right. For the other one, we can start with the negative 5. We have negative 1 goes down to negative 5. We have 0 is going to be negative 3, and so on and so forth, matching each and every point, and so on and so forth, going upward in this pattern. And you'll get a graph that looks like this, where the top one is the 2x and the bottom one is the 2x minus 3. Now, for each output value of y equals 2x minus 3, is the 3 less than the corresponding output value for y equals 2x? Well, in this case, it is, right? Every single value is less. Negative 7 is less than negative 4. Negative 3 is less than 0. Negative 1 is less than 2. And 1 is less than 4. And that negative 5 is less than negative 2. They all are less than. So that's absolutely true. The graph of y equals 2x minus 3 is the graph of y equals 2x, only it's stretched vertically 2 units. Now, we're going to be talking about this later, but stretching something means that we're going to be multiplying by a number. In this case, we didn't multiply any brand new number to go from 2x to 2x minus 3. So that is false. The graph of the y equals 2x minus 3 is the graph of y equals 2x translated down 3 units. If I take a look up here, I start at this point. If I were to go down 1, 2, 3 units, I am landing on every single one of these points by going down 3 units. And therefore, that's true. The graphs of y equals 2x minus 3 and y equals 2x are parallel. And of course that's true. They're true because they both share the same slope. Which, by the way, in the second portion, if it was a vertical stretch, they would not have the same slope anymore. Problem number 2, horizontal translation. The graph shows the projected altitude f of x of an airplane scheduled to depart an airport at noon. If the plane leaves 30 minutes early, what function represents the transformation? Well, right here is the original. We need to figure out which one of these graphs shows leaving 30 minutes early, which means that if we're leaving early, we aren't going to be leaving at the 0 mark, so we can cross this one right out. And we're not going to be leaving after the 0 mark, because that 0 mark is the original time. And therefore, the only option we have is the final one. And it is a little weird because it's not sticking with having that standard coordinate plane right there that we are so used to. It did move it over, so it is kind of a meh thing, but it does show that we are starting technically before the 0, and therefore this must be true. And now remember, this is a horizontal translation, so I'm thinking backwards right off the get-go. Everything seems to be backwards, because if I wanted to move something to the left, I would normally think subtraction. However, if I need to actually move something to the left, I know that it's going to have to be addition. And more importantly, horizontal on the inside of the parentheses as well. So I can rule out the second and the fourth portion, and now it's either the first or the third. But taking a look at it, I don't see 30 anywhere out here. So although it does say 30 minutes right here, that's not what we're talking about. We're basing it off of hours after noon, which means we're going to be talking about the f of x plus 1/2. So the next part is the reflection. If you are reflecting something, then you're going to be multiplying by -1. When you multiply by that -1, you have, again, two different outcomes. You have the vertical, which happens on the outside of the parentheses, and you have the horizontal, once again, on the inside. Now, they won't say it's a vertical reflection. what it will come up as is a reflection over the x-axis. If you think about the coordinate plane, if I have a point up here and I were to reflect it over the x-axis, it is going to travel downward to get to this new point. It is going to be going in an upward or downward fashion. That's why it's vertical. Whereas for the horizontal portion, if I were to reflect it over the y-axis or the opposite form, it's going to go from left to right because it's going to have to jump across the y-axis. And therefore, since it's going left to right, that is a horizontal transformation. Now, last little bit. How would we represent multiplying by -1? Well, again, if it's on the outside of the parentheses, it's going to be on the outside of the entire function. Whereas if it's on the inside, it's going to be right next to the x. So if you ever see a negative number in general, we are going to be doing some sort of reflection if we're multiplying it by the x or by the entire equation. Problem number 3. Let h of x be the reflection of f of x equals 3x plus 3 and the x-axis. What is the function rule for h of x? Well, circle the function that shows the f of x reflected across the x-axis. Across the x-axis is going to be going in a vertical motion because we're starting from the low point and we're flipping it over that portion into the upper part, or we're starting in the upper part and flipping it across the x-axis down to the lower part. So since that is happening, it's going to be a vertical transformation, which means that our negative that we're multiplying by, because it's a reflection, is going to be on the outside, and the choice would be the negative f of x. Now, can we write the function rule of h of x? In other words, can we put this into effect and come out with what h of x really is? If I were to plug this portion into the h of x, you're going to notice that we're going to get h of x equals a negative f of x, because that is what we said it was earlier. We're just taking the reflection. So h of x now becomes equal to a negative times the 3x plus 3. Well, how do we get the 3x plus 3? Well, f of x up here equals 3x plus 3. So if we know what f of x equals, we can plug in what we know f of x equals is. And therefore, that's why we get the 3x plus 3. And then finally, you just have to distribute out that negative that they gave. And therefore, we have h of x is going to equal a negative 3x minus 3. So if I were to graph both of these lines, I know that one's going to be passing through right here. The other one's going to be passing through down there. And this will be the graphs that we get. All right, so notice the graph going in a negative slope is going to be the h of x, and the graph going upwards in a positive form will be the f of x. But more importantly, the h of x equals negative 3x minus 3 is going to be the function rule. And last but not least, this is a two-parter. We have stretch and compression. Both are represented by multiplying by a number that isn't 1, and that's very important. All right, it cannot be 1, and technically we can't also multiply by 0 as well. So 0 and 1 we are not multiplying by, but any other number represents the stretch and compression. But the problem is we need to know which one's which. So let's start with the stretch. For stretch, you again have a vertical as well as a horizontal. Notice, vertical is on the outside of the parentheses, horizontal is on the inside of the parentheses. For it to be a vertical stretch, you must multiply by a number that is greater than 1. Hence the 2. 2 is larger than 1. 3 would work, 4 would work. Any number that is even a fraction larger than 1 will work and create a stretch. Whereas horizontal, it's a little bit different. Not only is it on the inside of the parentheses, but you're going to be multiplying by a number between 0 and 1. If that number is between 0 and 1, then it is going to be considered a stretch. So if you end up having a fraction or a decimal is the biggest tell for a horizontal stretch. So f of 1/2 times x would be a stretch. But more importantly, that is a stretch by a factor of 2, which I know what you're thinking. If it's by a factor of 2, why is it 1/2? It's because, like I said before, everything in horizontal seems to be its opposite, seems to be flipped. All right, so when we wanted to go left, that's why we were adding to go to the left. If we wanted to go to the right, we were subtracting. Well, if we wanted to multiply by a factor of 2 when we're doing a horizontal stretch, then we're going to make it its reciprocal. We're going to flip it upside down, and that's where the 1/2 comes from. What about compression? Well, let's think. If we have a vertical compression or horizontal compression, both of the inside and outsides fall in line just like they did before. But a vertical compression is actually going to be a lot like the horizontal stretch, in the fact that a vertical compression will be multiplying by a number between 0 and 1, which is a fraction or a decimal, and 1/2 f of x. But if you were to read this one and actually try and figure this one out, this one will say compressed by a factor of 1/2. So this one will actually legitimately come out and say, hey, you're going to be multiplying by 1/2, basically. And again, factor is just another word for multiplication as well. Now, horizontal is going to be very much like the vertical stretch. You're going to be multiplying by a number that happens to be greater than 1. But again, it's going to say compressed by a factor of 1/2. Horizontal is backwards. So instead of multiplying by 1/2 straight up like we did for the vertical, we need to make sure we take its reciprocal and flip it so it becomes 2/1, also known as 2. And that is probably the most important parts of the transformations. Remember, anything that is done vertically will be done on the outside of the function. All right, it's going to be done to everything is the best way I can put it. Horizontal, on the other hand, is done on the inside of the parentheses, which means that it's going to be done just to the x value, nothing else. And lastly, everything horizontal is opposite to what you normally do. Going left is addition. Going right is subtraction. When it comes down to stretch is the opposite. It will be 1/2, whereas the compression was 2. Okay? Always seems to be its opposite, backwards from what you normally think. Problem number 4, stretch and compression. For the function f of x in the table below, there is a corresponding table and graph for the transformation h of x, which is 1/3 of f of x. So how do we solve for h of x? Well, if we know h of x is 1/3 of f of x, and we know f of x equals 2, then we know that h of x becomes 1/3 of 2, which is 2/3. And we get 1/3 of the -3, which is going to become a -1 because the 3's cancel out, leaving you just with the negative and the 1. We have a 1/3 times 1, which is going to be 1/3. And last but not least, you have a 1/3 times that -2, and you get a -2/3. So again, plot all these points. Going to each and every one, we can start at -5. Instead of going up to 2, we're going to go to 2/3, which is probably somewhere around there. At -2, again, same thing. At 0, it becomes -1. At 3, it's going to become 1/3. And at 5, it becomes -2/3. So if I were to graph these points, I would get something that looks like this. And problem number 5, combining transformations. The function f of x equals x. The graph of g of x is f of x stretched vertically. All right, so we're stretching something vertically by a factor of 2. Factor means multiplication. 2 means that we're going to be multiplying by 2. Translated down. Down represents subtraction when we're talking about translation. So we're going to be subtracting 3 units. And more importantly, since it's vertically and down, we know that it's going to be done to everything as a whole. So what is the function rule for g of x? You must do what it tells you to do first, right? So the graph of g of x is stretched vertically by a factor of 2 and translated down 3 units. So I'm going to make sure that we multiply this original function, this f of x, by 2, because it tells you that it's stretched vertically first. Well, if we had to figure this portion out, we know that g of x, the very first step would be that we have to multiply that 2 times the f of x, which again, if we know what f of x equals, which we do, it's x, we can just get rid of this f of x and put what we know it's equal to. And therefore we get 2 times x, which is 2x. The function f of x equals x is stretched vertically by a factor of 2 and then translated down 3 units. Well, we have to make sure that we multiply it by 2, which is what we did. We already have that, so we know that we have a 2x. All right, the next thing is we have to show something that is translated down 3 units. Translating down means that we're going to be subtracting, and more importantly, since it's downward, it's a vertical translation, which means that we're going to subtract on the outside of everything, and we're going to be subtracting 3 units. So we can actually write 2x minus 3, and that is the correct answer. So the function rule for the combined transformation will actually be g of x is equal to 2x minus 3. And finally, we made it to the lesson check. So, very first, the graph below shows f of x equals 0.5x minus 1. Graph g sub x by translating f of x up 2 units and then stretching it vertically by a factor of 2. Graph h of x by stretching f of x by a factor of 2 and then translating it up 2 units. Compare the graphs of g sub x and h of x. Question 15. Graph g of x and h of x. Well, I am going to graph both of them right now, and you'll get something that looks like this. You'll have the g of x is on top going upwards, h of x is on bottom going upwards still, but it also looks like they're kind of parallel, but we'll kind of talk about that one a little bit later. So can you underline the correct word or expression to complete each sentence or equation? G of x and h of x are or are not the same function. Well, seeing how I see 2 lines, I know they are not the same function. G of x equals x plus 2, and h of x equals x. And they are going to be parallel lines. So, let's see where all of this came from. If we started off with our original function, that f of x, and we said f of x is going to equal that 0.5x minus 1. Our g of x says that we are going to take our f of x, and we're going to do a vertical translation of going up by 2, so we're going to add 2 to it first. More importantly, we're going to add 2 to the original function, f of 2 first, but then after that, we have to do a vertical stretch by 2. This has to be on the outside of the parentheses, and since we don't have the parentheses right now, and we know that that vertical stretch needs to happen to everything, I'm going to write my own set of parentheses in, and I'm going to make sure I multiply everything by that 2. Whereas h of x is going to be something very similar, but it's going to be its opposite form, right? So we're going to start by multiplying the f of x by 2, but then we have to make sure that we add a positive 2 to the end of that result. So let's see what the difference is truly between these two. So g of x is going to equal, well, we know what f of x equals, so I'm going to write parenthesis a 0.5x minus 1 plus 2 times 2. Simplify what's the best you can on the inside, so we get g of x is going to equal a 0.5x plus 1. And then we're going to multiply that by 2, so we have to distribute out that 2. And this is where we got the g of x is going to equal x, because 1/2 x times 2 gives you 1x, or x. And then that's going to be plus 2, and which is what we got earlier. Next, the h of x, we're going to make sure we multiply everything as part of the function first by the 2. So we have h of x is going to equal a 2 inside its own parentheses times the 0.5x minus 1. And then we're going to add 2 to that answer. So we have 2 times 0.5x, which we said earlier was the x by itself, so we just get an x. And then we have 2 times the negative 1, which gives you minus 2, plus 2. Now, there is no reason for these parentheses. As you can see, we're just adding on the outside. So this is really negative 2 plus 2, which actually cancel out, leaving you just with what we got earlier, which is the h of x equals x. And that is it, everybody. Congratulations. Great work. I hope you have a great rest of your day. Stay out of trouble. Don't do anything stupid. And I'll see you guys in the next one.